What if I told you that time travel is not just science fiction? What if I told you that you have already traveled through time today? That right now, at this very moment, you are moving through the fourth dimension at the speed of light? And what if I told you that the greatest minds in physics believe that traveling to the future is not only possible, it's inevitable? But here's the part that will keep you awake tonight. The future we can reach. The past, that's where things get complicated and dangerous and absolutely fascinating. My name is... And tonight, we're going to explore the real science of time travel. Not Hollywood stories, not comic books, real physics, real theories, real possibilities that scientists are working on right now. Let's start with the simplest truth. You are a time traveler. Every second of every day you move through time. You travel from this moment to the next, from today to tomorrow, from this year to the next. Time moves forward and you move with it. But here's the question that has haunted humanity for thousands of years. Can we move faster? Can we skip ahead? Can we go back? The answer, according to Einstein, is yes and no and maybe. Einstein's theory of relativity changed everything we thought we knew about time. Before Einstein, time was simple. It ticked the same for everyone, everywhere, always. 1 second on Earth was 1 second on Mars, 1 second on a distant star, 1 second everywhere. Einstein proved that was wrong, completely, utterly wrong. Time, Einstein discovered, is flexible. It stretches, it compresses, it slows down and speeds up depending on two things: how fast you're moving and how strong the gravity is around you. This is not theory, this is proven fact. This is tested every single day. Let me give you an example. The GPS system in your phone. Every time you use Google Maps to find a restaurant, every time you call an Uber, every time you check your location, you are using time travel technology. Here's how it works. GPS satellites are orbiting Earth at 17,000 miles per hour. They're moving fast, really fast. And because they're moving so fast, Einstein predicted that time would move slightly slower for them than for you on the ground. But here's the twist. The satellites are also farther from Earth's gravity, and weaker gravity makes time move faster. So you have two effects working against each other. Speed slowing time down, less gravity speeding time up. The net result? The clocks on GPS satellites gain about 38 microseconds every day. That's 38 millionths of a day. Sounds tiny, right? But if we didn't correct for that difference, if we didn't adjust those clocks to account for Einstein's relativity, GPS would be wrong by about 6 miles every single day. Your phone would tell you the restaurant is on the left when it's actually on the right. Your Uber would never find you. So every time you use GPS, every single time, you are relying on Einstein's discovery that time is not absolute, that time can be bent, that time travel is real. But that's just the beginning. That's time travel on a tiny scale. What about real time travel? What about jumping years, decades, centuries into the future? Einstein said it's possible, and he told us exactly how to do it. The faster you move through space, the slower you move through time. It's called time dilation, and it's not a theory. It's been measured. It's been proven. In 1971, scientists put atomic clocks on airplanes and flew them around the world. When the planes landed, they compared those clocks to identical clocks that stayed on the ground. The clocks that flew, they were slightly behind. They had experienced less time. They had traveled just a tiny bit into the future. Now imagine doing that with a human. Imagine building a spaceship that could travel at near the speed of light. Not 17,000 miles per hour like GPS satellites, but 100 million miles per hour, close to the cosmic speed limit. If you got in that spaceship and flew to a star and back at near light speed, something incredible would happen. For you on the ship, maybe 5 years would pass. You'd age 5 years. You'd grow a little older. But when you came home, Earth would be different. Maybe 50 years had passed, maybe 100. Everyone you knew would be old or gone. You would have traveled to the future. You would have lived 5 years, while Earth lived a century. This is not science fiction. This is physics. This is what Einstein's equations tell us. This is what we know to be true. The problem is engineering. Building a spaceship that can go that fast is difficult. The energy required is enormous. The technology doesn't exist yet. But the physics is solid. So, future time travel? Possible. Proven. Just waiting for us to figure out how to build the machine. But what about the past? What about going back? Seeing dinosaurs, visiting ancient Rome, stopping yourself from making that embarrassing mistake in high school? That's where things get weird. Einstein's equations actually allow for travel to the past. They don't forbid it, but they require conditions that are extreme. The most famous idea is a wormhole, a tunnel through space-time, a shortcut that connects 2 points that might be billions of miles apart or billions of years apart. Imagine space-time as a piece of paper. Normally, to get from one side to the other, you have to travel all the way across. But if you fold the paper, if you bring the 2 points together and then punch a hole through, you've created a shortcut. That's a wormhole. Now, if you could create a wormhole and then move one end of it at near light speed, time dilation would affect that end. It would age differently. And suddenly, you have a tunnel where one end is in the present and the other end is in the past. Step through, and you've traveled back in time. Sounds perfect, right? So why aren't we doing it? 3 problems. Tiny little problems, nothing major. Problem 1, we don't know if wormholes actually exist. Einstein's equations say they could, but we've never seen one, never detected one. They might be purely mathematical. Problem 2, even if they exist, they're probably microscopic, smaller than an atom. You're not walking through that. Problem 3, to keep a wormhole open, you need something called exotic matter, matter with negative energy, matter that repels instead of attracts. We don't know if that exists either, and if it does, we have no idea how to make it. So wormholes are possible in theory. In practice, maybe someday, but not soon. There's another idea, an even stranger one: cosmic strings. Cosmic strings are hypothetical objects left over from the beginning of the universe. Think of them as cracks in space-time, extremely dense, extremely thin, infinitely long. A single cosmic string could be denser than an entire galaxy, but thinner than a proton. If you took 2 cosmic strings and moved them past each other at high speed, theory suggests they could warp space-time enough to create closed time-like curves, paths that loop back on themselves, paths that lead to the past. But again, hypothetical. We've never found a cosmic string. We're not even sure they exist. Then there's the most famous time machine of all, the Tipler cylinder. Frank Tipler was a physicist who proposed that if you built an infinitely long cylinder and spun it at near light speed, it would drag space-time around it and create loops that could lead to the past. infinitely long cylinder. That's the problem. You can't build something infinitely long. It's infinite. So that idea, while mathematically interesting, is practically useless. So far, everything we've discussed is theoretical, possible on paper, impossible in practice. But there's one more idea, one that doesn't require exotic matter or cosmic strings or infinite cylinders, one that uses something we know exists: black holes. Black holes are real. We photographed them. We've detected their gravitational waves. We know they exist. And black holes warp space-time more than anything else in the universe. Near a black hole, time slows down dramatically. If you could orbit close to a black hole without falling in, you would experience time much slower than someone far away. You could spend an hour near the black hole and return to find that 100 years had passed on Earth. Future time travel, using nature's own time machines. But what about the past? Could a black hole take you backward? Some scientists think so. Inside a black hole, at the singularity, the laws of physics as we know them break down. Space and time swap places. The future becomes a direction in space. The past becomes a direction in space. It's possible, theoretically, that inside a black hole you could find paths that lead backward. But there's a catch, a big one. You'd have to survive the journey. And black holes are not gentle. The gravity would tear you apart, stretch you like spaghetti, kill you long before you reached any time travel destination. So black holes are great for going forward, not so great for going back, at least not alive. Now let's talk about the paradoxes, the reasons why many physicists believe travel to the past is impossible, even if the math says it might be possible. The grandfather paradox. You go back in time and kill your own grandfather before your father is born. Then you are never born, so you can't go back in time to kill your grandfather. But if you didn't go back, your grandfather lives, you are born, and you do go back. It's a logical contradiction. It makes no sense. Some physicists say this proves time travel to the past is impossible. The universe wouldn't allow such contradictions. But others have proposed solutions.
The Novikov self-consistency principle says you can travel to the past, but you can't change it. Anything you do in the past was already part of history. You always were there. You always did whatever you did. So if you go back to kill your grandfather, you will fail. The gun will jam. You'll change your mind. Something will prevent it. History is fixed. Then there's the many worlds interpretation. Every choice creates a new timeline. You go back and kill your grandfather? Fine. You've created a new universe where your grandfather dies. But in that universe, you were never born, so you can't be there to kill him. Wait, that's still a problem. Actually, the many worlds version works like this. You go back in time, your presence creates a new branch of reality. In that branch, you kill your grandfather, but you still exist because you came from the original branch. You're a visitor. Your existence doesn't depend on that branch's history, so no paradox. You just can't go back to your own original past. You can only visit alternate timelines. This is getting complicated, and that's the point. Time travel to the past is so weird, so mind-bending, that even the best physicists in the world can't agree on whether it's possible. But here's what they do agree on. Time travel to the future is real. It's proven. It's happening right now, all around us, on a tiny scale. And someday, maybe someday soon, we'll figure out how to do it on a large scale. Imagine a world where you could skip ahead, watch your children grow up, see the future, know what happens next, then come back and tell everyone. Or imagine a world where criminals are sent to the future instead of prison, 100 years in the future, where society has advanced beyond crime, where they can start over. Or imagine exploring the far future of Earth, seeing what humanity becomes, visiting the stars without spending generations on a spaceship. Just jump ahead 10,000 years and see where we ended up. This is not fantasy. This is physics. The hardest part is speed. To get significant time dilation, you need to move at a significant fraction of light speed. That's hard, really hard. But scientists are working on it. New propulsion methods, nuclear fusion, antimatter, even more exotic ideas like warp drives. Yes, warp drives, the thing from Star Trek. Believe it or not, there's real science behind it. In 1994, a physicist named Miguel Alcubierre proposed a way to warp space-time that didn't break the laws of physics. Instead of moving through space, you contract space in front of you and expand space behind you. You're not moving, space itself is moving, and because you're not moving through space, the speed limit doesn't apply. You could effectively travel faster than light. And if you can travel faster than light, you can also travel through time. It's all connected.
The Alcubierre drive requires exotic matter, just like wormholes, negative energy. We don't know if it exists, but the math works. The theory is sound. It's just waiting for us to figure out the engineering. So where does that leave us? We know time travel to the future is possible. We've done it on a tiny scale with atomic clocks and airplanes. We know how to do it on a larger scale. We just need the technology. We don't know if time travel to the past is possible. The math allows it, but the universe might forbid it. Paradoxes might make it impossible, or they might not. We have theories, wormholes, cosmic strings, black holes, Tipler cylinders, Alcubierre drives, all mathematically possible, all practically impossible with our current technology. But here's the thing about impossible. It used to be impossible to fly. It used to be impossible to go to the moon. It used to be impossible to talk to someone on the other side of the world instantly. Impossible is just a word we use for things we haven't figured out yet. The scientists working on time travel today are like the Wright brothers in 1900. They know it's possible. They know the physics works. They just need to figure out how to build it. And when they do, when the first time machine is switched on, everything changes. Imagine the first time traveler, not some Hollywood hero, a scientist, an engineer, someone who spent their entire life working on this moment. They step into the machine. They set the dial for 100 years in the future. They press the button. And then they're gone. What do they see when they arrive? What does the future look like? Are we still here? Did we make it? Did we go to the stars? Did we destroy ourselves? They'll know. They'll be the first human to see tomorrow. And maybe, just maybe, they'll come back and tell us. That's the dream. That's the goal. That's what drives the physicists and engineers working on this problem right now. Because time is the most mysterious thing in the universe. We move through it every second of every day, but we don't understand it. We don't know why it flows one way. We don't know if it can be reversed. We don't know if it's fundamental or emergent, real or illusion. But we're learning. Slowly, painfully, incrementally, we're learning. Einstein taught us that time is flexible,
that it can be stretched and compressed, that it's connected to space in ways we never imagined. Modern physics is teaching us that time might be even stranger, that at the quantum level, time might not exist at all, that particles can be entangled across time as well as space, that the future might influence the past in ways we're only beginning to understand. There are experiments happening right now that hint at these possibilities. Delayed choice quantum eraser experiments, Wheeler's delayed choice experiments. They suggest that at the quantum level, decisions made in the present can affect what happened in the past.
Not time travel as we normally think of it, but something strange, something that suggests our classical understanding of time is incomplete. So where do we go from here? Forward, always forward. That's the only direction we can control right now. But someday we might go back. And on that day, the first time traveler will step out of their machine and look around at a world that remembers them from history books. A world that knows they were coming, a world that has been waiting. Maybe that traveler is already among us. Maybe they're here now, watching, waiting for the right moment to reveal themselves. Or maybe they're you. Maybe someday you'll be the one to step into the machine, to see the future, to visit the past, to become part of the greatest adventure humanity has ever undertaken. Time travel, real science, real possibilities, waiting for us to figure it out. The clock is ticking, it always is, but someday we might learn to tick backwards. And on that day, everything changes. What would you do if you could travel through time? Where would you go? What would you change? What would you want to see? Think about it, because the science says it might be possible, and the future is waiting. This is Digman, signing off. Keep looking forward, keep wondering, and remember, you're a time traveler already. You just haven't learned to steer yet.